Alright, have hit the button and we'll see what happens. So far nothing's happening, which is a little strange. But anyway, I'm sure it'll catch up. I'm pretty sure. It's just sure enough. Leave it at that. Seems like it's working. Yeah, seems like it. Alright, so more whatever. Argue the argument kind of thing, but it's getting hard to get people to stay on the subject and actually respond to the points that have been made. So I could say over and over and over again, 350 years and they don't have a single experiment showing it taking 4 times the fuel to go twice as fast. A pretty amazingly informative. If it's a fact, we really should all experience it in some way through at least an experiment that explicitly shows it to be true. Even though I personally didn't have any life experience that indicated it to be true. I can't really think of any circumstance where, I found out that, when I drove faster, I used a lot more gasoline. But anyway, doesn't matter. To some extent, because they're not going to argue the argument. Okay, so this is a video by Gosling, Some Thoughts. Wow, 20 minutes. I didn't realize it was that long. All the rest of them are little junky 1-minute videos where he proves something. So I guess we'll do this KE one first, where he's saying the Mythbusters are wrong or something. And then we'll go back to this 20 minutes worth of... Oh, it just must be horrible to watch. But anyway, we'll watch some of it. The Dispar guy did finally post a video of him dropping weights, and it's really not much of a video, not much better me doing it on my porch or whatever, drop a weight and see where the scale goes. So we did the 1 mass and then the half mass from 4 times the height of the 1 mass, and from his observations anyway, they appear to weigh the same in terms of their impulse weight, their momentum. That's what the scale is measuring. So that's what I titled the video, because it's pretty much that's your mass doesn't have any weight outside of gravity. So gravity is what gives it weight. It makes it move the scale. Is it needs some force that pushes it in one direction, so it can push on the scale in one direction and cause the needle, the spring, to move. So when you're in gravity, as we are right now, there's 9.8 meters per second of a force pushing on each one of your little atoms, and each little atom catches that force, okay, and moves because of it, and that's what you're detecting. And then the Earth has to push you back up and start you over again. So you bounce in gravity. So I don't know if there's some other way to say it. You oscillate in the gravity, if you want to be more technical, because of the circumstance where the Earth's pressure pushes you back. It's just that simple. It pushes you back to point A. You go to point B, it pushes you back to point A. You go to point B, it pushes you back to point A. And that's all that keeps happening as a net product. Okay, so we can't see the real cause. We can just see the effect. The effect is it keeps pushing the spring in because it constantly does this. Okay, now part of the time it's going the wrong way and it weighs nothing, but part of the time it weighs something. So it's, yes, the weight is probably a representation of half the amount of force that you're actually pushing in with, because half the time you're pushing back out again. Something like that. Not that complicated, really. Certainly as a theory, certainly within in the realm of called reasonable, it explains the phenomenon. It works. So what's the big deal? Why the hostility? Because somebody else suggests a working theory, you have to somehow point out how it doesn't work when it does? It's just not any logic to this at all. So, hopefully everything's working appropriately. Let's see how much volume we need here. We'll try it there first. All right, so this is his minute attack, 1 minute against the Mythbusters video. I don't think it'll be worth much. Let's see what. Maybe we'll look at the comments first. Just as a bit of fun. Let's see. I guess we better do this sort thing just in case. Let's see. The spring paradox. The two equal weight objects are placed on. Were placed of separate springs. So two equal weight objects were placed of separate springs, and the springs compressed by 1 inch, which means 1 inch of gravitational potential was used. Well, no, it means that the time it takes for something to fall that distance is the amount of time gravity pushed it and gave it a velocity. It accelerated it for whatever, 27 billionths of a second, whatever the number was. And through that process, that's an accumulated amount of velocity. You have to accumulate the velocity through increments of acceleration. So if your acceleration is 30 miles an hour, your acceleration could be 0.000030 per trillionth of a second. See, so that's how it works. And so you accumulated a number of units of times worth of gravity. The paint spray can sprayed on you a certain amount of time, and in that certain amount of time, a certain number of particles of paint hit you. The sun shines, and you stick your, collector in it for a certain amount of time. The amount of time you have the collector pointed at the sun will decide how many photons it collects, because the sun produces a consistent number of the photons. Gravity does exactly the same thing. It isn't a controversial thing to say, in the sense that there's no, except for you saying there's no rational counter argument that that's not exactly how gravity works, that it's almost could be described as radiation. And it's about how long you're in the radiation decides how much radiation you collect. And the radiation could just be called weight. How much weight you collect depends on how long you're collecting it. And you can't collect it when you touch something else. Okay, the idea is that whatever radiation is hitting you goes right through you into the other thing. So it's like electricity, and you discharge. So anything you're collecting, you just become a conductor, and it goes into the other thing you're connected to. In total, 2 inches of gravitational potential is used. So again, it's kind of silly to talk about inches when you really have to be very careful and understand that, well, the inches equate to an amount of time. So if I spend 2 inches of distance at, say, 50 miles an hour in a paint sprayer, that will calculate out to a certain amount of time in which the paint had an opportunity to hit me. But that's all it is. It always reverts to the amount of time. Okay. Next, place both objects on a single spring. Okay, the spring compresses the 2 inches. Okay, so far so good. That's Hooke's law, so this isn't complicated. 1 pound moves a spring this much, 2 pounds moves a spring this much. Each object used 2 inches of their gravitational potential. So again, he's just going to keep talking as if there's some good reason to think of gravity as a distant force, a force that's in where distance matters, where distance is the direct cause. When it says 9.8 meters per second, so it doesn't matter how many times I point out it's per second force, he's just going to keep saying it's a per foot force or a per inch force, when that's only true if you have a constant velocity. All right, the total 4 inches of gravitational potential is used. What? Yeah, no, sorry. So again, just, more nonsense. That's not the rule. See, the rule is that you do have to acquire the same instantaneous. The action has to happen at the same time, and that's what makes the difference. You can't punch somebody with 25 pounds of pressure and then stop, and then hit them again with 25 pounds of pressure, and then say, I hit them with 50 pounds of pressure. You didn't. It's not 50 pounds. 2 30-pound bursts is not a 60-pound burst. So you're just demonstrating that you have a very thin exposure and understanding of the concepts involved, frankly. That's what I'm seeing. Are you quoting someone? Have to look at Paradox Explained, a link in comments of some thoughts. Oh, so he has, the video actually played. Yeah. Oh, okay. He has to go see the video I already played and argued. Oh, interesting. Of course, the paradox wasn't explained in any way whatsoever. He just made a convoluted defense and ended up throwing relativity into the argument, which just makes the argument even more abstract and disconnected from anything real, because clearly none of these velocities have anything to do with speed of light paradoxes. Gonna be a long day.
Just to finish what I was saying about the Mythbusters experiment.
Okay, so apparently he said something about it in the previous video.
Gary was saying, how do you explain?
I'm just saying, on its face, okay, it's a pretty good piece of evidence indicating nothing close to the kinetic energy theory being realized. So like Brozo's billiard balls, it just doesn't look good for your side.
That the one velocity squashed the clay sample an amount, and twice the velocity squashed it twice the amount.
Right, exactly as the cars came out. So 50-mile-an-hour crash looks like this, 100-mile-an-hour crash looks like that. So it came out exactly the same way, which is perfectly consistent with momentum being in control of moving objects. You move an object with momentum, the momentum is transferred, and the momentum does the deformation of the other object or itself.
Twice the compression. And he says that's twice the energy. So where's your kinetic energy gone?
Yes.
Well, I think that's wrong. I think inadvertently, this wasn't the object of their experiment, but they actually ended up proving kinetic energy.
So it doesn't make any sense at all, okay, that somehow we know how weight works and we know how springs work, and this object is just duplicating what a spring would have done, and it's sort of Hooke's law kind of an argument. The elasticity or the deformatability of the object, if it has some sort of consistency, it will demonstrate and do the same thing the spring does, except it doesn't store the energy. So things that deform can deform by a Hooke's law rate, in the sense that it's a consistent rate of deformation. And there's absolutely no evidence that these objects are in any way reluctant to be deformed at some point.
Because I think that this clay sample cylinder behaves similarly as a spring would.
Yes, exactly. And so you're making my point for me. The spring is measuring the weight. It's measuring how much weight, pressure hits the clay. And that's all it's measuring. And there's absolutely no indication of any 1.4 thing.
And to squash this cylinder to twice as much would take 4 times the energy.
Not by Hooke's law, not by Spring's law. So springs don't do that. You keep saying springs do it. I keep pointing out how that's impossible. I show you the experiment that demonstrates it to be impossible, in the sense that this can't be 4 times the energy. One piece of energy in, and then I put a second battery on it. It goes twice as, I'm going to break something. I put one finger on, okay, my finger, and it weighs. And then I slide the second finger on, and it weighs twice as much. I didn't do 4 times the work. So that would be free energy if it was 4 times the momentum, 4 times the weight, and I only did the work of moving twice the weight. That would be free energy again. But whatever, there's no arguing with the belligerently stupid, so whatever. Just keep believing nonsense because mommy told you, or whoever you're getting this from. Again, why don't you just link me to your physics professor who says exactly what you're saying? Because they don't say exactly what you're saying. They convolute. They play games with words. So they rationalize the double slit experiment. They never say to you, well, the single slit in water does not produce the same pattern as light in the single slit. So the two are not similar. They don't say that, but that is the absolute truth.
Like a spring would. I think they're very similar. So actually, inadvertently, they've proved kinetic energy theory.
So again, he's arguing that Hooke's law isn't true, okay, because there's no other way to interpret it. And he's claiming that springs conserve kinetic energy, they don't conserve momentum. These are bold statements against everything. I can show physics lecturers saying the exact opposite. I have shown them saying the exact opposite. And so he's arguing with conventional physics, MIT and Stanford and Yale and all the places I've played videos from. He's arguing those professors misunderstand. But he obviously isn't directing his argument at those people. So it's just such a waste of fucking time. But anyway, let's just finish this piece of shit.
By squashing the cylinder twice as much. So that's how I would explain it.
Well, it's an insane, frankly, explanation. It doesn't explain anything how this equals 4 times the energy. Doesn't explain why it takes 4 times the energy to go this far and it only takes 1 time the energy to compress this. The clay started this big, let's say. So it only took 1 time the energy to do this, but it took 4 times the energy to do that. There's absolutely no explanation for why that would be the truth, why that's a fact.
It's a complete win for kinetic energy.
Alright, so what a silly video, frankly. I mean, they even point out while they're making the video, hey, this isn't consistent with kinetic energy. I mean, they even say the words, for fuck's sake. And then in the next segment in the video, the guy actually sits there with a tin can and tries to rationalize it by saying, see, tin cans aren't consistent in how they crush. Well, that doesn't explain why the clay wasn't consistent. And it's certainly not applicable because we know each device has its own structural mechanisms. Okay, I mean, I imagine with crushing cars, there's a point where you can't crush it because now you're just moving pieces of steel, and the steel's much too hard. There's no air left over to get out. And just like there's the end to the spring, and you can't compress the spring anymore because it's metal against metal. And of course you can reach those points, but it'll be a hell of a coincidence that it just happens that the speed they did both experiments at was exactly the right speed where they reached that maximum compression point. And with the clay, you can't even come up with any maximum compression point, frankly. It doesn't make any sense. I mean, the clay it isn't harder to crush when it gets this thick versus this thick. It's still going to squish out the same rate. So this is basic physics, and they obviously are too ignorant to make a reasonable physics argument to explain. So they just make up, crap. And frankly, it's just plain crap. He's saying when you see half the clay crushed that somehow that's looking at, he's basically saying this is 4 times the pins knocked over or something. When the rate at which the pins are getting knocked over by the bowling ball is the same, and how the hell is this 4 times as many pins? It's not 4 times as many. It's on its face a nonsense argument. All right, so that was, as predicted, not very useful. I could show the dispar video, but there's really no point, right? So I guess I won't bother at this point. I mean, you know, there's no audio, there's no argument made. He just drops the things on the scale, and you see the scale, and he doesn't slow motion, he doesn't do anything to make it more visible. He just concludes that his analysis demonstrates that they're pretty close to the same weight. So half the mass from 4 times the height, twice the velocity, will compress the spring the same amount, okay, as the 1 mass from 1 unit of distance at 1/2 the velocity. Just as Professor Lewin stated was the basic physics rule. So again, they're arguing with Professor Lewin. They're really not arguing with me. See if there's anything in the chat, just because who wants to do this shit? I don't want to interact with anybody. It's all it's all below my pay grade, frankly. Light does not move, everything else move. Okay, well, you're really dumb, you know. I mean, you take the name Argo, like there's some magical Argo spot. So I don't know what troll you are exactly. I mean, you could be Farley. But yeah, really stupid to say the whole universe moves when a photon from Alpha Centauri reaches here after, you know, whatever, 3,000 years. What the fuck? I mean, it's just a ridiculous statement, you know, frankly. Ridiculous. It's ridiculous, frankly, for so many reasons. I mean, you could waste an awful lot of time trying to debunk just these liars. You know, I saw a UFO. Oh, okay, I have to explain to you why that's not really possible, that you saw anything of significance. And so it takes a lot more work to debunk just these lying statements these people make. And so they really suck. Liars suck. Light clone itself on medium. Yeah, well, go fuck yourself. You're just making statements that are just irrational mush, so you can just fuck off. You're not of any value to anybody. This isn't taught by physics. You either argue my arguments or you argue conventional physics, but you don't do this, whatever this crap is, you weak-ass piece of shit. This flat earth and crap. Oh, fuck off. God damn. The audience is just so pathetic. Humans. Again, people are actually defending like there's some reason for anybody to have a baby that grows into one of these fucking cretins, these stupid, ignorant turds in their fantasy, fable-y, crappy, shitty, trolly existence. Ugh. Sorry about being long-winded. Okay. Well, let's see if you said anything that could possibly be related to reality. That is, are you defending any real physics? Looks like he just wants to play with the silly math formula that has a square in it. The very one that was in the paradox that just points out, well, yes, I mean, if you believe in mv squared, you can do this. But it's not necessarily going to give you the right answer, because we're not going to prove what the right answer is, because regular physics won't do the experiment. Hilarious. I mean, there's not that much to this, right? I mean, in the sense I've already showed things that are, in my opinion, you know, they really can't debunk. You know, the whole idea that if you roll a ball on a surface, that it goes 1/2 the speed after it travels 3/4 of the distance. It's doing exactly what gravity does, because gravity's creating the friction, and the friction is the way you're measuring the energy, as you're measuring how much energy leaks out of the object. But you people just can't do this logic thing. Alright, let's get rid of this. Again, that was disappointing, actually. Like it's all disappointing. I shouldn't. So, well, yeah, we have a mindless marbles comment. Oh, that would be exciting. And he links to some other video. The video dealing with lifting weights to compress a spring. So I don't know whose video that is. But again, I've already argued this argument. It's about units of time. And obviously 2 10 mile an hour, if you have two 10 mile an hour crashes, it's not going to equal a 20 mile an hour crash unless it happens at the same time. So you can increase the pressure. It has to be an increase the pressure. Tapping something like that. If I tap it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that does not equal one tap that would have been 10 times more powerful. Those two things aren't equal. So anyway, let's play the video. Yes, if 10 100-pound people walk across you and cause you some discomfort, it's not going to mean anything. But if all 10 of them, okay, get together and step on you at the same time, then it's going to mean something. Duh.
Bit of a boring one for a lot of people. It might be a bit long. I've got so many topics to cover here. I'm just going to
what kind of mess you'll make
waffle
of
on a
them?
bit and see how it goes. I reckon my storage will run out of memory on this phone. I'm having trouble now. I've been deleting everything off of it, but it's still it ain't got enough memory, it says, so it could cut out. Might be a blessing in disguise. I'll see how we get on. I've got to hold my hands up, Gary. That video I did with the weight on the treadmill.
Yeah, it was just ludicrously stupid. Okay, it had nothing to do with the argument I made. Okay, it's not about traveling scales. It's about the weight being on the scale for a period of time. Not, it's like on the spring. Okay, so it has nothing. Obviously, I'm saying any distance you're equating has to do with time. The distance is only relevant because you could use it as a measure of time. If you know what velocity it's traveling, then the distance is clearly going to tell you exactly how long it was exposed to something or how long the weight was on it. I mean, there was no way to do this except by deliberate perversion. I mean, I didn't leave any room for any idea that I was talking about. I'm sitting here overtly saying it's how far you travel across this spring. How could somebody convert that into, no, I mean, you put the weight on it and leave it there and then you just move the scale. That's the same thing. I mean, nobody reasonable could have made that mistake. So obviously this is where their agenda shows that they don't care about the truth here. They don't care about the facts. They will just, deliberately and willfully mischaracterize the argument. I mean, it's just malicious lying nonsense. It's not my argument. I've said it over and over now. You just keep drawing it as if it's my argument. It's not my argument. Go fuck yourself, you lying sack of shit. The argument would be about real gravity. In real gravity, the spring is essentially the ground. Okay, you're flying across it, and you fly across the scale, the whole Earth. Nobody says, well, I moved the Earth at 70 miles an hour. No, that's not making the car move 70 miles an hour across the spring. That's not 70 miles an hour worth of distance, okay, on the scale. Oh, you're just such a liar.
That was a bit of a funny, really, I suppose.
Well, you drew it again.
It wasn't moving through gravity, was it? It was stationary. So, But John Walker suggested, what about if we put the scale in a car and move the car along the road with this?
So I'm just saying, what honesty can you believe these people have if they've converted an argument about walking a certain distance across a scale? You're only on the scale this long, the distance you're going across it. You could be going 60 miles an hour. You could be going 120 miles an hour. You go 300 miles an hour across the spring. You don't have contact with it any longer than the time it takes to get from one end of the scale to the other end of the scale. How could anybody convert that to, I put the 300 pounds on and then I move the scale up, down, here, 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 here. Look, the scale doesn't change. It says 300 pounds no matter where I go or no matter how fast I travel. It's the same. Who could do that and call themselves honest? Come on. It's such a complete perversion of everything in my argument. And again, I went through the whole argument how it's like a paint sprayer. It's like raindrops. I'm making the point that obviously if you're leaving the weight on the scale in the rain, it's going to keep measuring. The scale is the measuring device. It's about how long the object is on the measuring device. It's not where you travel with the measuring device. Who cares where you travel with it? Oh, I mean, what a pathetic liar.
Scale on the front seat or in the footwell or something, and a weight on the scale.
So he starts this video by saying, "Oh, I'm going to be wasting some time. This is going to be a little bit long, but there's some really interesting concepts, maybe or blah." This isn't interesting. This is a complete, absolute lie nonsense. I didn't suggest anything like this. I didn't say this principle has anything to do with a principle. This is just nonsense. I mean, this is the best you can do? Is this insane perversion of what I say into a cartoon that can only be done in a cartoon, frankly?
Measure the weight, stand still, not moving, and then go up fast, say 70 mile an hour. Do you think that scale is going to read a different weight? Is it going to lose weight? Because now...
That's already happening. We're already moving through space. This planet's spinning. There's all kinds of motion going on, and the scale reads. It doesn't change because the planet's moving. Idiot. Unless the planet accelerates, and of course it will move.
If you're thinking of, the gravity, like rain, particulate in nature, you say as we go through the gravity, less hits you, or you absorb less gravity, so it should weigh less. I just wonder what you thought of that experiment, because that's...
It has absolutely nothing to do with what I'm talking about, right? You're not moving the weight across the scale in a unit of time. You're leaving it on the scale, and you're pretending time doesn't matter, and time is everything I've been talking about. 9.8 meters per second. I've been talking exclusively MGT. I've been titling videos. It's all about the time, and here you have an experiment where you just say, I'm just going to fuck time in the ass because... that's your agenda. You're going to ignore the argument I made and make this. This isn't a straw man, right? I mean, this is a poo man, okay? This smelly poo argument, and say I have to waste my time talking about why this doesn't work. No, I shouldn't have to waste any time explaining why this isn't what I argued. No, I shouldn't have to. If the other side had any integrity, they wouldn't make arguments this bad. They wouldn't waste the audience's time with arguments this fucking unrelated to what's being argued. The argument was take the weight and move it through the paint sprayer, not leave it in the paint sprayer.
Although it's a theoretical experiment, it's feasible. It could be done. On the subject of moving through the rain, apparently, no matter how fast you run through the rain, the same amount hits you. It doesn't change.
That's a lie. Okay, so Mythbusters did that one too. So that's just more nonsense. Now, obviously, if I spend an hour in the rain, I'm going to get a lot wetter than I spend 5 minutes in the rain. Everybody knows that. Any moron can figure that out, and it doesn't matter whether I move or I don't move. I'm not going to change that, okay? So it's about how long you're in the rain. Now, if you're in the rain the same amount of time, then you're going to get the same wet. Okay, so it doesn't matter how fast you go if you have to run further to get out of the rain. But if you're running faster, going from point A to point B, and you're only in the rain while you're between those 2 points, the fact is you can evade how wet you're going to get by running faster. Just a complete mechanical necessity of reality. No idiot should argue that isn't true. They're just demonstrating they're fucking idiots. So again, this guy really shouldn't deserve a reply anymore because these lies are getting so insane. He can't defend that logically, that it doesn't matter how fast I go through a paint sprayer, I get the same paint on me. That would be every idiot knows that can't be true. The faster I go through the paint sprayer doesn't change how much paint gets on me. Fuck you in the ass, you're a retard. Now, obviously, some of the paint I want to hit that's already in the space. So I'm guaranteed a certain minimum. But every increment of velocity I apply will reduce the number of paint particles that hit me. Or
the faster you're going, you're running into more rain, sort of thing. So I don't know whether your analogy is right at all, actually. But just to clarify that.
So it's moronic. You can't run into more of it, okay? There's only a certain amount that can fit in that unit of space, and you won't run into more of it, okay, by going faster. You'll run into less of it by going faster.
In case you're, having a fit at the moment. Let's take the example of a fan here, whizzing around. It's blowing out air. This is a fan. As we move something past the fan, yes, the faster you move that ball or whatever, throw something through this wind, the less the force.
Less it's pushed, yes, exactly, right. So gravity's just doing exactly the opposite of a light bulb, doing exactly the opposite of a paint sprayer or a rain cloud. So it's all just the opposite direction, but it's the same exact principle.
So the less time the force is acting, so it will deflect the ball in this direction less, because there's less force acting per unit of time, isn't there? Oh, right, you've said this.
Yeah, exactly. And all the force producers are operating under that kind of standard. They all take time to produce force. They can't put an infinite amount of force at any one moment. So, yes, most devices have a rate at which they can produce force.
There's a planet, and we're flying through in a spacecraft. Yeah, it's a similar thing, but let's keep it on Earth, because everything really we got to do is related to what goes on the surface of the planet. Let's be practical, So yeah, as you go through this fan,
I don't see why it would be more practical not to consider planets. That's what Newton did, and it's perfectly reasonable to explain it more completely. The force happens from an atom to an atom. The force exists in all material objects, create this force. So I think it's important to do it show that it works in all cases.
Less force is going to hit you. But that doesn't apply to this business that you were talking about, rolling a ball along.
Okay, I didn't talk about rolling a ball along. I talked explicitly, again, let's just say it again. I said, let's take a piece of the road out and put a scale in. So the road's here and the road's here, and there's a scale over this little section. And then all you have to do is take a vehicle or anything and just run it across. And the faster it runs across, the less weight will be registered on the scale, the less this energy detector will detect, meaning the less energy that actually goes into the road. It's just basically telling you how much pressure are you putting on the surface of the road. This will be measuring it. The slower you go, you see that it's more pressure per foot. The faster you go, it's less pressure per foot. That's the story you're perverting, and I went over it so many times and said it in so many different ways that there's no way anyone could pervert it honestly. You're doing this is just theater. You're a lying, shyster, conniving, crooked lawyer or something. You're just sitting here making up little fake nursery rhymes to try to get your guilty murderer off. Okay. You have bad physics, and you're trying to rationalize it by completely perverting what the other person has said. You're a despicable human being, a despicable shithead. All right. Let's see. They have done the clay experiment with other shaped objects. Well, why don't you show us that? Or with balls, have they? Going deeper than halfway to get rid of the bias for velocity. Well, if they had done them that way, then we would already had the right answer, right? So obviously they didn't do them the right way. Just as they haven't done the two-slit the right way. They don't do it the way that shows you the experiment doesn't work. If they do the two-slit experiment with something larger than infinitesimally small slits, guess what? It actually creates a double-slit pattern that has two patterns in it that's not explained by Young's drawing. So obviously it doesn't fit. It's not the Young double slit experiment because it's an actual double slit experiment. And an actual double slit experiment, physics has no clue how that pattern is created. Okay, so it's the same thing. If they did the experiment correctly, then we'd have the correct evidence and we'd understand why there's a difference. There's a difference. It depends on whether the arrow is pointy. That decides how far it penetrates the object. The pointiness has something to do with the penetration depth. Duh! For fuck's sake.
On the surface, and the faster it rolls, the less gravity's hitting it. Because you're...
No, it's just idiotic. The less gravity is hitting it, it's too stupid. It's the same amount of time, okay? You got to figure out how long it's on the scale. It's obviously not going to be on the scale that long. If the W object is moving, it's clearly not going to be on the scale as long as if you move the whole scale. So you're talking about gigantic differences in velocity, in the sense of gigantic differences in the amount of exposure to the force. So it's like drawing this fan diagram and starting using round lines or something. Well, what if I go from point A to point B by zigzagging over here and then going over here and going over? Isn't that the same experiment? No, it's not the same experiment.
You're moving along on the surface of the Earth, and the gravity's not changing. We're not.
The time
from this point here, we're outside of the wind flow or gravity, and at this point here, we're in the wind flow or gravity, and then we're out of it again. But going along the surface of the Earth, you're never out of it. It doesn't change. It's constant in it as you go around the surface. So the amount of gravity you're in.
Right. So he's saying it's if I was measuring how far you were going this way across the object, it's the same as going in the horizontal direction, staying in the gravity entirely. So he's saying so you're staying in the gravity the whole time. That is, you don't ever get to point B. You just keep going in here to any amount of time. So if you made this a square and said you're going to go the same amount of distance this way, well, then you might have the same experiment, but you didn't do that. Okay, so you're just saying I'm going to leave it in the gravity a lot longer. I mean, that's a simple argument. But again, this is so clear that how do you mess it up, right? I mean, there's absolutely no reason to change an experiment where you're saying I have a scale, it's on the ground, and I'm going to move across the spring. I'm going to only spend a little tiny amount of time on top of the spring. How can you fuck that up as an analogy? It can't be, there's absolutely no reason to do this to it. Oh, but what if I put the scale on wheels? I don't give a fuck. The thing that's going to be important is how long is the object on the scale. It's a time-dependent force. I'm arguing it's a time-dependent force, and you're changing the amount of time it's on the scale. Too stupid.
It doesn't change wherever you move. So I can't see that analogy working. But I just wondered what you thought about this, because we would be moving through the gravity, and would we see a difference on the scale?
Yeah, you're moving through it, but you never get a point B, so you never go across the gravity. You don't go... It's absolutely nothing to do with what I talked about. Nothing. It's like a paint sprayer analogy, and he's saying, what if I'm going this way and that way in the paint spray? Aren't I out of the paint spray? No, you're still in the paint spray when you're going this way. You have to go across the paint sprayer, across the sun's exposure. You can't just sit in the sun and then jump up and down and say, I'm getting less sun because I'm jumping up and down. No, you're not getting less sun. Duh.
You were talking about doing it with all little scales on here, on the surface. The trouble with that is because it's a mechanical device, I don't think they would have time to register. There would be a delay in them registering the weight.
So he's saying the scales don't work. Yes. No, I'm saying no, they do work. The pressure will be applied, and the fact is it's just less pressure. Less time means less pressure. It's just a fact. Because it's clearly being governed by gravity is providing the energy. And all you're doing is measuring how long is the conductor connected to the meter that's going to detect the voltage. How long is it connected? And it's not connected long enough to collect anything more than the little impulse of gravity.
And be accurate. Possibly you could do it with some very high-speed electronic pressure sensors or something that didn't have to deflect much. Perhaps you could tell. But what about this? We do away with all this sort of kit and just
High tech, all that high tech stuff doesn't do the analog stuff well at all. It doesn't measure impulses. It just measures averages over time, and that's not going to work. You need something that measures the total net weight. And springs are pretty good at doing that.
put the scale in a car, move the car along the road fast. What would happen? Anyway, that was that. So, what do you think about that? I don't want to keep going on about this business. 9.8 metres a second. Oh, that's right. Yeah. F equals ma, doesn't it?
Fuck you.
Well, you won't agree with that, but anyway, that's what science says. And I was thinking about weights dropping in, falling to the ground in gravity. This acceleration force is the same everywhere.
It's a rate. It's a rate. It's a rate. You don't square the rate. You count how many times the rate happens. That's the whole per second thing. The rate happens, 9.8 meters. It's an amount. You get that amount when you go 1 second. When you go 2 seconds, you get 19.6. You go 3 seconds, you get 39 point blah, 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 whatever the hell it is.
On the Earth, although it does vary apparently.
And again, who cares? We're talking about things in a gravitational potential, okay, that's going to be rather consistent. So everybody knows it's 9.8 meters, yes, but on Mount Everest, it's whatever, 9.79 meters per second. Who cares?
It changes slightly from equator to pole. But anyway, for all useful purposes, it stays the same. 9.8 metres per second squared, they call it.
They call it.
Yeah.
So again, no. Why do they call it that? Okay, that's not what Newton said. So again, you just keep saying I have to believe this crap. That's all part of your made-up fable. Okay, Newton didn't say 9.8 meters per second squared. Newton didn't say 9.8 meters per second in any other form than to say yes, it can happen in as many seconds as you'd like. But clearly, Newton said force equals velocity. He said you want to double the velocity, double the force. Those two things are the same. And those basically add up to force equals your momentum. How much force you apply will equal an amount of momentum. No matter where you add that force, it will always convert to momentum, a velocity, and a mass.
Whether this is a big mass or a small mass, we know that if we drop them, they hit the ground at the same time. I think, strangely.
Yes, they collect an amount of energy consistent with how many atoms they have, how many electrons and protons. The electrons and protons are the surface you're spraying the paint on. And you're just calculating how much paint did I hit these objects with without that paint being taken away. So if I thought of it as electrons, the universe was throwing electrons at these objects and making charge on them. You could understand that, yes, if I connect them to something, they're going to lose all their charge. But if they stay in free fall, okay, they will collect electrons at a rate because I'm shooting them at a rate. A certain number per second of electrons are hitting the two objects. And they can only collect the charge based on their size. How big are they to collect the electrons? The electrons have to stick to them. So you're basically just saying their surface area is consistent with, okay, what you could call their mass. So we have to just say these are equal density objects just to be fair, and yes, they're the same shape. You don't make this one flat and thin, and you don't make this blah, 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 blah. But whatever. It's the same idea. You're just saying the surface you're collecting it on is atoms, and it doesn't matter where the atoms are, whether they're flat or whether they're this shape, they collect paint at the same rate.
But I was thinking about it. The acceleration doesn't change, but the mass has changed, doesn't it? Now, if the mass has changed, then the force has to have changed. If we increase the mass...
Yeah, you're increasing the amount they collect. You're not increasing the amount that's affecting them. The paint spray is the same for the two objects. Obviously, the small object gets less paint on it because it's a small object, so it's got less force pushing less matter. This one has more paint on more matter. So those two numbers remain proportional, or the same, essentially. You can't change that because the matter is collecting the force. So less matter, less collected. Doesn't mean gravity changed. It means you're collecting less of it. So obviously when they hit the ground, the only thing that's going to be revealed is how much charge did they collect. How much electricity or wattage are they holding? The big thing collected lots of electrons. It has lots of wattage. The small thing collected very few electrons. It has very little wattage. And that's what you see when they hit the ground. The feather doesn't do shit. The lead ball makes a big hole and shoots a bunch of bits into the air.
Acceleration stays the same. The force must get more for the bigger ball than the lighter ball. The less massive ball must have less force on it.
On it. See, you keep saying force on it. No, it's the same force. They're collecting different amounts based on their mass. So again, he keeps fucking it up. Force equals velocity. It's the same thing, okay? And so if they were the same size, the same mass, then you'll get the same velocity because they'll collect the force at the same rate. They collect at a rate, and the force is emitted at a rate. If the two objects collect at the same rate, then they'll move at the same speed. If they're collecting at different rates because of their difference in mass, okay, then obviously they'll collect a different amount of force. I mean, this is just ABC kind of stuff. You really shouldn't have to argue it. There is no counter-argument to what I'm saying here. This is perfectly consistent with everything that happens in the physical universe. There's absolutely nothing wrong with the theory that gravity can be understood as, okay, a quantized force that you acquire over time.
Then the bigger massive ball. Because if force equals mass times acceleration, they'll keep the acceleration the same, but the mass changes, then doesn't the force have to change? I'm not a physicist, and I'm not a mathematician.
Yeah, and you're not a decent person either. You're not a reasonable person. You're just a lying, shyster, propagandist moron who keeps saying things that you... Again, I've quoted Professor Lewin. You say he's wrong. You're not a physicist. You don't know what you're talking about, yet you're saying he's wrong. All right? And yet you're not explaining why you know he's wrong. You're saying you don't have to, springs don't conserve momentum. It's a bold statement, motherfucker. Saying levers don't conserve momentum. It's a bold statement, fucker. You have to take some responsibility for your bold statements. You're not an expert, but you just keep talking shit.
I'm just an interested party, interested in the truth.
No, you're not. If you were interested in the truth, you wouldn't quit misparaphrasing the argument and running away from every fucking argument I make. It's 9.8 meters per second, okay? Putting a square on here is not, in my opinion, rationally defendable. You don't 9.8 meters squared. It's not 9.8 meters squared. It's 9.8 meters once, it's 9.8 meters twice, it's 10 times, it's 100 times. It's 9.8 meters per a number of times, and the times can be in second divisions, in units of time. It could be hours, it could be days, it could be any unit of time, but there's no squaring. There's just a number of times this happens. You can have in a half a time, 5.4. Yeah, it's got to be a 4, right? Yes, 4.6, right? Something like that. Or it can be larger. 4.9, sorry. So get it right. Quit playing this game that you're doing anything consistent with what I'm saying or even with conventional physics is saying. You're just talking from some fucking UFO planet, making up your own fucking rules about what has been established and what is believed. And it's just a lie. To imply the force is different on the objects is idiotic. It's the same goddamn force, and it's really just about how much the object collects, and the collection is based on its mass. And to argue anything else is just logically unviable. Let's see if there's any comments by the putrid, silly shitty commenters. Doesn't look like it, but I'll look anyway. Okay, I had to argue in Ian's comment section why MGH is wrong. Yeah, well, I mean, obviously it's it's wrong if you want to get the right answer. So yes, it'll get you the right kinetic energy answer, but obviously if you think 4 times the height is actually collecting 4 times the gravity, when again the argument is if it's only in the gravity twice as long, how can it collect 4 times the force? If it's only in the paint sprayer twice as long, how can it collect as much spray as it would have collected if it was in the sprayer 4 seconds, 4 times as long? How could it possibly do that? That doesn't make any sense. It's about how long you're in the spray. That analogy is perfect, and they won't touch it with a rational argument. All right. Cowards and evaders and liars and scum. All right. Continuing.
And I like to try and intuitively understand these things because they're not easy to understand. I don't know whether this will help anybody out there.
All right, so why didn't you counteract? I've used paint spray, I've used rain. What else have I used? And I've used little quanta of BBs even. That what you're collecting, okay, is a weight in the end. So you can metaphor it as weighted objects that you're actually collecting, or you can metaphor it as bits of momentum that will be revealed as a velocity. But again, you're really just saying how much of this force stuff, the paint or the water, are you collecting? That's the velocity part. You're collecting it on your surface, and you can just measure it based on basically a contact argument. How much have you had contact with? And if you had contact, that means, and you didn't lose your charge. I mean, I've used electrons as an argument. You have to collect the force, and the mass is the collector. So I think the bucket in the rain argument, are you realistically paying any attention to my argument and explaining how the bucket in the rain doesn't work here? It works perfectly. The big object, big bucket, little object, small bucket, you're going to measure how much they collected, how many beans of energy they collected. And the beans are falling at the same rate. So it's kind of obvious that the small bucket collects a small number of beans, the big bucket collects a gigantic number of beans potentially, and potentially, makes a giant hole in the ground because of all the beans it collected. I mean, fuck.
Confusing, but so if the force on the big ball has now increased, the gravitational force hasn't increased, is it? But this equation says that if this is going to be equal to the product of this, and we change the mass, then surely this has got to go up. So if the force has gone up on the big ball...
I mean, obviously, it doesn't go up, okay? So it's really stupid to say that the force changes, okay? That the gravitational force changes. So it's just stupid, in my opinion, to say that you're going to do the equation backwards and say mass equals acceleration divided by the force or something. I guess that's what you're doing. But obviously that's about how much you collect. It's not the rate. So you can't use this argument and say the force is 9.8. See, you put it over here as if this is equatable to this force you're talking about, as if it was gravity. And we already know that gravity is a constant force. So it's an unviable argument.
Why isn't it moving faster? It's not moving faster, is it? Because acceleration stayed the same. They hit the ground. I think, this is my light bulb moment, it's because of the greater inertia.
Oh, here it is
the
again.
Greater inertia.
Okay, so again, inertia is just mass, okay? So there is no... I'll quote physicists saying that it's just mass. It's not some special function. All right, big things, more mass to push. You have to spread the force over more bits of more atoms. You have to push more atoms. It's more work is involved. Just a fact. Not complicated. So yeah, if you want to say this one has more mass, therefore it collects more force because it has more atoms that collect the force. The atoms collect it. If you don't understand that analogy, and it works perfectly, that's exactly how it functions. the small universe is the only universe. I have to say it over and over again, but that's where it all happens, and all you're doing is moving material bits, electrons and protons, and it's just how many electrons and protons are you moving? Are you hitting with a force?
Because of the greater amount of matter, is balancing the greater force now. The greater force is having to be applied to move this greater inertia. I think that sort of intuitively helps you understand these things a lot more, and all of these.
Okay, I again would just argue that no, I think the most sensible way to describe it is the mass collects the force. So the more matter you have, the bigger your bucket is, the more gravitational potential energy you're going to collect, and you're going to collect it just like you would collect rain, or just like you would collect paint.
Problems is probably related to this. I know you hate the idea of the inertia, but it is, whatever you want to call it, resistance, well, you don't like that. Inability to absorb energy, you call it, whatever you want.
I know, yeah, I know, no, there's just no point in saying it. It's just obvious that if it's bigger, you have to apply more force because the force has to be spread over the whole piece of bread. So again, if I'm making the argument that I'm throwing the same piece of butter at two pieces of bread, and one piece of bread is gigantic and one piece of bread is a little, Cheez-It, and I have the same amount of butter, well, which one's going to have the butter on it thicker? Obviously, the big thing, the butter has to be spread really, really thin, okay? That's it. But there's no resistance to butter. The bread isn't saying, don't put butter on me, okay? It's just saying that if you're going to, it's going to take a lot of butter because I'm big. That analogy solves any problem you're having logically understanding, okay? There's no way you can't understand that simple concept of spreading something over a bigger surface and understanding if I spread over a bigger surface, it's going to be a thinner layer. Per inch or per molecule of bread, there will be less butter.
Call it. It does exist, this inertia. So, yeah, there you go. I think that's now what else was it? Now, the energy stored in a spring. Potential energy is 1/2. So I'm going to forget. Kx squared, isn't it?
Yeah, and they're just replacing the other symbols with new symbols, so it doesn't mean anything. Okay, it's the same fucking equation, the 1/2 and the square, and it's just totally not useful. Nonsense. It's just made up extra crap you're throwing in here. And obviously the point is that people who want to get the right answer actually just say PE equals x kx. Just the spring constant times distance, the distance. And that's frankly written as a law.
Press the spring. It goes up the square of the energy. Now here we go. Here's a word. Exponential. I know you call it exponential, but these words are important.
No, they're not.
And I think a lot.
No, they're really not. Okay, nuclear. Who cares? I mean, you want to play little word games. You want to say that's important. You're so full of shit. It's just incredible. I mean, these are the least important aspects of physics, is whether somebody says bolosity or bolosity. Bolosity, I could say bolosity. You don't get what I'm saying, then you're pretty fucking god stupid. I say buckosity. You'd still know what the fuck I was talking about.
Your problem, Gary, is you're trying to reappropriate the language.
I'm not trying. I'm deliberately mocking the language, okay? Because the language is bullshit. I mean, I should come up with something to point out that there's no such thing as a scalar or balar or smaler or smaler. Your scalar crap is just made up faggoty crud, okay? That has nothing to do with reality. It's a little baby word. Scalar, all of a sudden we don't know which way it's going, even though it's on train tracks and it's plowing ahead at 50 miles an hour. We don't know which way it's going. Yeah, that's fucking idiotic. It's a scalar.
Now, if you think about it, if you were going to argue with somebody in Abu Dhabi or whatever, and you couldn't speak English, anyway, you was writing about his language he was using, and you wanted to you were arguing that his words weren't right, and you were trying to redefine the words they use in a given language, an age-old language. And you
Oh, like English? And all the way you say stuff that's really creepy? Yeah, like, oh, there's so many English terms. Calling a cigarette a fag. I mean, there's lots of things you do. They're just too silly.
to redefine those words. You're going to come unstuck. Nobody's going to want to talk to you.
Oh, who cares? I mean, again, nobody who matters. Okay, that's right. All the people who don't matter won't want to talk to me, because only people who can't stay anywhere near a subject, or want to evade the subject, or want to cop out or run away, all the little cowards will worry about whether you spell a word right or whether you say it right. Now, you can mock each other now and then about how you say shit, and that's okay. I'm about to go on my boat. I'm about to go on my boat. Yeah, you can mock shit. But so what? No one's going to make the argument, oh, I couldn't get your argument at all. I couldn't understand what you were saying. Fuck you.
You can understand that, can't you? And it's the same in science. You've been reappropriating words like momentum and other words.
No, I'm reappropriating language, and I'm saying there's no point in saying random because it's nonsense. There's no point in saying spontaneous because it's nonsense. There's no point in saying instantaneous because that's also nonsense. So all of these words are broken, okay? And we all have to have a conversation still using them in some kind of rational way. So we all should probably qualify when we say random, we should say randomized, random-like. Some other term to recognize that we're not saying that there's actually some random God somewhere that randomizes something, because nothing is random in reality.
Your definition of what you imagine, how you imagine things should work. I'm sorry, you can't do that. You either got to come up with new words, or leave the words alone and use them in their correct setting. That's like Hooke's law.
So what's this? What is this waste of time, really? I mean, can you get more desperate? It's pretty desperate that he's putting the scale on the car instead of the car on the scale. But it's really desperate, right, when he starts saying you have to draw your P's with this little dot here. If you don't have a dot here on your P, then it isn't a real P. And the E has to have no top E thingy. So your E has to be a T. So if your E doesn't look like a T, you haven't drawn a proper E, and I can't have a conversation with you. I mean, this is just such a fucking goddamn waste of time. Fuck you. Fuck you. Fuck you. Oh, you can't say fuck you. Yeah, I can. I just did it. Fuck you. Silly shit.
Now, you keep talking about Hooke's law as a proper thing. You don't say it's rubbish. You say, yes, Hooke's law is correct. The deflection of a spring is proportional to the weight.
I played the video where the guy made all the qualifications and pointed out, well, yeah, I mean, it's correct to a point, okay? It's not too great at the first little compression, and it's not too great at its last compression. But the shit in between is pretty consistent, so yeah. And I went a step further and pointed out what you're really measuring is the coil differences. All right, and that's what you really should be measuring, is the distance between one coil of the spring and another coil of the spring, because anything you put at the top won't be compressed and it won't be part of the measurement. So you have to be kind of careful that you're really measuring coil distances, like as if you were wrapping coil around a conductor, to create a solenoid. It's really important how far apart your coils of wire are.
Put on it, but you don't mention that Hooke's law doesn't talk about energy. Hooke's law doesn't deal with energy at all.
Well, I never said it did. I don't need to point that out. I'm just saying that I'm pretty confident that this scale measures momentum, and I'm arguing that momentum is energy. So weight is momentum. I can have something with momentum, and I can crash into the scale sideways, and it'll do exactly the same thing it does in gravity. It will measure something's momentum. That's my argument.
But just talks about the weight applied to a spring. Now that brings up another thing, because you're talking about, well, haven't we got free energy? If we lift a weight up, plonk it on the scale, and then lift another weight up, and it's doubled the compression of the spring, not scale, on a spring, and we've got 4 times the energy, according to this rule. That's right, we have.
Again, he says that's right, we have, and I'm saying, of course, this is obviously the wrong answer, and it's PE equals KX, and there's just no squaring it, no half. It's all nonsense. Absolutely no reason to add this crap except to get your fake number and your fake joules that are never real things. So if you want the fake wrong answer, that's how you do it. Hold on a second. Right, continuing.
Now, I spent a long time, well, not a long time, but 10 minutes on a video trying to painstakingly go through why that argument is wrong. Now, you seem to have forgotten about it. I think it was called a spring paradox or something, and I dealt with that very problem.
Liar. I mean, I dealt with that very problem, and I pointed out how you're just talking nonsense, okay? It's not about going down a staircase, okay, 1 unit of time, 1 unit of time, 1 unit of time, 1 unit of time, because you're not gaining the Galilean velocity. You're not doing what free fall does, which is accumulate, okay, the time in 1 unit. If you break the time into pieces, you don't accumulate the force.
Because I wondered why you couldn't do it. And it turns out that you actually would use more energy lifting weights up to compress a spring than having a machine do it. That video...
I don't even know what that means, but I pointed out you could just slide the weights onto the scale. It doesn't matter how you get them on the scale. The point is it takes the same amount of energy to do the second weight as it takes to do the first weight. And obviously the second weight is the one that does all this extra work you're claiming. You're claiming the second compression takes more work than the first compression. And the argument being made is, no, it doesn't, because gravity's doing the work, frankly. So you're not propelling something into a target. And again, it matters whether you do 2 10-mile-an-hour impacts at different times, or you do 2 10-mile-an-hour impacts at the same time. Those things do matter to most surfaces. Now, it's the same energy, but the fact that you put both of them in a smaller unit of time means it will cause more damage or more impact. But the two things hitting will have the same impact damage, right? So you could understand that if I was to hit something, you know, with the closer I bring the two things together, right, they're going to hit a surface 10 feet apart. They're going to do some damage to the surface, and they'll have some damage. Well, it won't, their damage isn't going to matter how close I bring the two things together, but the damage they do to the other object is going to matter the closer I bring them together.
I tried to explain it in that video quite carefully. That just shows you don't listen very well.
Fuck you. So go ahead and play the part in my video where I didn't listen, okay? I played your fucking video, something you haven't done for me. You haven't given me that courtesy of actually playing my actual arguments. Instead, you sit there and put my scale on a conveyor belt and do all kinds of wacky shit that had nothing to do with anything I said. So you're the one who was accused of being a grotesque perverter of the argument and completely disingenuous in your fucking lying sack of shit nonsense paraphrases that aren't even close to what I'm saying. So you're the one clearly not paying attention, or more exactly evading the actual argument, evading it.
Because you're sort of gobbing off all the time. You're not listening for a minute to what other people are saying. You might learn something.
Fuck you in the ass.
Go back to that. That's a. Well, I think you call it a straw. That's another straw man argument. That's another thing.
Just die as horribly as you possibly can, you motherfucker. How dare you accuse anybody else of a straw man when you have this ridiculous drawing in the fucking goddamn image, just showing you can't take anything seriously, you can't do anything honest. I mean, what a pile of scum you are to lie like this. You accuse somebody else of straw manning you? What a pathetic liar you are.
Your bloody straw man arguments. lifting weights up onto a spring and compressing them, we end up with more energy in the spring because we've doubly compressed it. Kinetic energy says, and this formula says we've got from here. That's a straw man argument.
It's not a straw man argument. It's a Professor Lewin argument. And again, you pointed out there's a law governing it, okay? It's not 4 times the weight. It's not 4 times the velocity. It's not 4 times the time. I can go through all those 2's again and point out to you, okay, that you drop something in gravity. 4 times the height, twice the velocity, twice the weight, twice the time. And you just keep saying 4, 4, 4, 4. And you keep saying, I don't have to pay attention to how much time it's in the gravity. I don't have to pay attention to it's only twice the velocity. I don't have to pay attention to the fact that it's only compressing the spring twice as much.
Use more energy lifting the weights up. But you'd have to think very carefully about it. You like to say that you're the only one who think you're the great physicist. You think in detail about these details. Well, you're missing.
I've never said anything like that. What I'm saying is you're apparently, the human race is full of liars like you who can't take anything seriously. They can't do anything upright and honorable. You're all just lousy, stinking pieces of scum. I'm on a planet of scummy bugs, okay, scheming and conniving to keep their unicorns alive, and that's all there are here. People want to feed their Jesus. They want to feed their unicorn. They don't want to do a goddamn thing that has anything to do with taking responsibility for being on this planet, a sentient being, a thinking being, and actually doing any of it with anything called integrity or honesty. You're all just denying, conniving, lying sacks of ugly, stinking, smelly, fat shit. And that's a very sad circumstance that I'm living in. On a planet full of complete and just utter gaping asshole. And you're just proving that theory.
Things, I can assure you, you're missing things. You need to think a little bit more carefully about this, and specifically about this problem with lifting weights up, compressing a spring.
So he's saying this in spite of the Professor Lewin direct statements, half the mass, twice the velocity, in spite of Professor Lewin pointing out that you have to conserve the momentum, and he keeps saying there's no such thing as conservation of momentum. And he's telling me I have to do more thought. And he's too gutless to title the video Professor Lewin's full of shit. He won't do that. This lying sack of dishonest scum won't sit there and say who he's really disagreeing with. It's just despicable. Despicable. All right, let's see. So things with a bigger surface area. Again, I pointed out its density really because atoms don't care about whether they're behind each other, in front of each other, blocking each other. None of that makes any difference because the force goes right through them to the next electron, blah, 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 blah. So it's about the density of the material, you could argue. All right, area that have the same mass fall faster in gravity. Yes, if you change the shape of an object, it will have a different gravitational point. So they already figured this. They already did this. So, this is one of the few experiments in the 2000s that are capable of doing that are a little bit interesting. So they actually sent a probe up to go, crash into a fucking asteroid. And before they did that, they measured its gravity. And the fact is, its gravity over here was a little bit more than its gravity over there, and it's a little more than its gravity over there because of the shape of the object. And the same thing happens on Earth. And they discovered that 200 years ago, though. Where they went to different places on Earth and they found that the gravitation is a little bit off. The 9.8 thing doesn't work because if the mountain is made out of lead, you get more gravity. If there's all kinds of little irregularities that mean that you're going to actually create more or less gravity because there's more or less mass between you and the center of the Earth. Blah, 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 blah. So yes, that's a fact. Shithead. All right, but you're not going to see it with little tiny objects, moron. All right. Butter analogy helps. Oh, good. The British sure are condescending. Well, they sure are smelly asses. Okay, if compound interest, fuck you, is the most powerful force in the universe, I think it's time to block you. What is the second most powerful? So why shouldn't I block you will be my question to you. Why should I not block you? So you can answer that question, or I'll block you. Yeah, that's what you could do. So do that with your next comment. Explain why I should not block you, or I will block you.
Why you don't have free energy. Takes a bit of thought. It's difficult. It's not intuitive.
Oh, fuck you.
Yeah. So this problem, I was going to... This kinetic energy, measuring kinetic energy is very difficult.
All right, just because of the thought thing and the fact that he's pretending that there's something he needs everybody else needs to do a little thinking. So for 2 years, I have requested them to draw a lever and explain how it works, and he won't do it. So he's made this 20-minute video, and it appears it's not going to have a lever in it anywhere, right? He's not going to do what I've asked for 2 years. Again, another obviously cowardly evasion of the actual argument. So I did a simple experiment, right? And this is something nobody should disagree. This works, okay? Fulcrum. Whoops. Let's put the fulcrum in the middle. It doesn't look like the middle, frankly. So we'll move it over a little bit. That looks a little better. All right. And so I put a 1 mass here, and I put a 1/4 mass here. Okay, 1/4. All right, 4 units of distance. So we're doing the 4 units of distance thing just to compare the gravity thing, blah, 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 blah. And what am I going to get on a lever? So a lever is a little different. I'm going to get a movement here. If I put a force in, I agitate the balance. Okay, so I agitate the balance with a force, a fixed force, fixed. All right. This 1 mass moves this much. This 1/4, I don't know why I wrote half, moves 4 units of distance. So 1 unit of distance, 4 units of distance. Okay, so it's just like gravity. And the fact is, there's no way of denying that this is going to oscillate. Okay, that I proved. I showed. I experimentally demonstrated, at least in my section of planet Earth, it oscillates just fine. This going 4 times the velocity of this in the same unit of time. They're fixed. They have to do this. They can't not do it. This is a straight, rigid piece of hollow steel. Anyway, not bending, not any of that crap. There's no inertia. There's no elasticity. There's no all this baby talk. And so all I have to do is put enough force in to actually cause it to lift off the lever. And what would the expectation be, right? This is going to go. This has got to be, okay, 4 times the velocity. There's no choice. It has to leave with 4 times the velocity this would jump off the lever at. So whatever way I put the force in, if I put enough force in to make it lift, it's going to have to lift at these ratios, okay? This is going to be 1 velocity, and this is going to be a 4 velocity. And there's no way I can undo that, and that's the conservation of energy and momentum that Professor Lewin talked about. You're obligated to conserve the momentum. There's no way you can change the force. So if I put the force in this way, I create this little velocity and this little movement. If I put the force in this way, I create this high velocity and a small mass. By their theory, somehow if I put the force in this side, I get, say, 400 joules of energy. If I put the force in this way, somehow I only get 100 joules of energy. Now, momentum says you get exactly the same. Everything works just fine. This is the same energy over here. The 10-ton train going 5 miles an hour, same as the 5-ton train going 10 miles an hour. Same energy, same ability to change the universe. The 1,000 atoms, okay, moving 1,000 miles per hour, okay, equals 1 atom, okay, moving 1,000 atoms, okay. Draw 1,000 atoms moving 1 mile an hour. Okay, these two things are equal. They're going to do the same thing in the universe. They have the same power, the same ability to create wattage and work. Okay, they're not different things. They're not 1,000 times different. There isn't 1,000 times more potential to do work. Okay, 1,000 times more potential to do work in the universe over here. 1,000 times more watts. Okay, there's not 1,000 times more watts here than there is here. So this is the argument. 2 years, no rational counter argument that I have slandered the truth somewhere here. They believe in a theory that is a free energy theory. It doesn't work. It doesn't make any sense. Things can't oscillate with unequal energies. The whole point of an oscillator is you're moving the energy one way, then the other way, then this way, then that way. That's what an oscillator is. You can't have 1,000 joules of energy going this way and then only 1 joule going that way, and 1,000 this way and only 1 joule that way. That won't oscillate.
It is very difficult. Even demonstrating the energy stored in a spring is very difficult. You would need some, well, it's complicated electronic equipment to measure the energy.
So this is just totally inconsistent with the sensible observation that springs are pretty reliable in their collection and storage of energy. So yes, whether springs are 80% or 85% efficient, well, I don't know what the actual number is. I think there's springs that are more efficient than other springs. So we could argue about this K value or efficiency value. But you could argue that with batteries too. Some batteries store the electricity more efficiently than other batteries and release it. So leakage and all that kind of stuff, they all have different kind of mechanisms, flywheels, how efficient they are. You can find lots of objects and you can measure their efficiency. But the whole idea basically is that all these devices can do, okay, is manipulate energy put into the system. And they manipulate it by shifting it or storing it, and there's nothing else going on. It's energy in, energy out. There's no way the energy can be destroyed, and there's no way to create free energy. And basically you're arguing in defense of a free energy theory that does say that somehow I just by shooting the gun the opposite way, by holding the gun rather than holding the bullet, I can make the explosion have a different amount of energy, and you can't make the explosion have a different amount of energy.
Be released from a spring by doing some work, either electrically. It's not easy to do. Not very difficult, actually.
Oh, I mean, it's just such nonsense. I mean, they've had 300 years to do these simple experiments. It's like saying the Eddington experiment is very difficult, really, when now it's so simple. You don't need an eclipse. You don't need a spectacular telescope from space. And it takes 5 minutes. It's just absolute bullshit to say, oh, there's this huge technical barrier. We can't do it. No, there's no technical barrier. There's no technical barrier for them to actually measure correctly and precisely and, in some respectable manner, conduct these experiments and show us the tug of war between the 5-ton train going 10 miles an hour and the 10-ton train going 5 miles an hour. Show us the tug of war and show us the 5-ton train decisively winning. Decisive. Twice the energy. You need another 10-ton. You need 2 10-ton trains to stop that 5-ton train. That's their theory. The energy of 2 10-ton trains going 5 miles an hour is required to stop the 5-ton train from winning. That's their argument. And it's on its face silly shit.
And I was trying to think of something we could do. Because I believe that dropping a weight twice the distance would give you 4 times the work. How to show it?
Well, that's just idiotic. It's not gonna. It's 4 times the distance, get twice the velocity. So twice the distance won't give you twice the velocity. So your drawing is incorrect.
How to show it? And that's where this come in easy, because you were saying, oh, I've done this. I'm quite satisfied that dropping the weight, one speed gives you this, and dropping the weight twice the speed gives you.
He's quite satisfied and hasn't done it. Okay, so go ahead and do the dropping one. Okay, you did the launching one. Now do the dropping one and show us. But then you'd have to film whatever's at the base of your experiment, which you seem reluctant to show us how exactly you have these springs configured. These multiple springs, by the way, not tied together.
Twice the weight. You're quite satisfied with that, you were saying, And then when I brought up, why don't you try dropping half a mass, twice the speed, suddenly you're changing your tune. Why should I do it? It's a rubbish. I've got...
Liar, I didn't change any tune. I did the first experiment shitty. I did a shitty version to satisfy myself. I explained that. I don't understand why I should bother tying two batteries together and then dropping them on the scale from one distance and then dropping one battery from 4 times the distance, I have absolutely no doubt what the outcome is going to be. So why the fuck would I waste my time?
Rickety old scale. I've got in the basement. I've got no facilities. Why should I do it?
Exactly.
And yet, you were quite happy to use this as an advancement of that you were right. And that's something about you.
I didn't use it. I used the fact that it's 4-to-1 relationship. I used what Galileo proved 500 years ago. So don't lie some more. I mean, I already know this is true. Okay, that experiment has been repeated over and over and over again. We know it's 4 times the height to go twice the velocity. It's already a done deal. I'm certainly making the observation that I found out that twice the velocity is in fact twice the weight. That's all it's going to weigh. 4 times the height, only twice the weight. I'm just pointing out that there's a clear correlation between momentum, velocity, and weight. And I've pointed that out that you could just do it by running into a scale sideways. I don't have to use gravity. I can just run into a scale sideways and I can deflect the scale a certain amount. If I run twice the speed with the same mass, hit the scale, I will deflect the scale twice as much. Twice the speed, twice the momentum, twice the energy. Not 4 times the energy. Twice the energy.
It's like Waterlooing. Cool, I'm all over the shop here today. It's like Waterlooing. 1 minute, when it suits you, Waterlooing says, nature can't finagle momentum. It has to conserve momentum. Nature can't.
Okay, so it's not suiting me. It's just a fact of their physics. So again, you're the one saying Professor Lewin and all the other physicists are wrong to say conservation of momentum is a real thing, a deep thing, a profound thing, a meaningful thing. You're saying it's somehow not as meaningful as they claim it to be. You're saying to NASA, fuck this mass and velocity shit. It's really not that. It's not all that.
Nature can deal with kinetic one way or another. Great. Why don't you answer that? Twice the force, twice the velocity. Why don't you deal with what Walter Lewin says? On the other hand, you've spent videos decrying the man, calling him all sorts of names. Specific.
Yeah, it's about the arguments being made. It's not about the character of the person. Again, I'll call him kind of a pervert. He's lots of things, but what the hell is that relevant? I'm just saying that yes, there's arguments made where conventional physics has the evidence, and then there's arguments he makes that he doesn't have evidence for, like 2 voltages in one place, and he's too stupid to figure out the probe wires are part of the experiment, and he can't rely on those voltage readings because the probe wires are being affected by the experiment. Not a complicated argument. Frankly, and he sit there and counter-argued by saying anybody who disbelieves in anything I say is a flat earther. So it was pretty lame. Yeah, so what? I mean, is somebody saying this is Professor Lewin is perfect? No. I don't think anybody would argue that. I'm just saying that these are arguments not being made to Professor Lewin, where I have made them to Professor Lewin. So again, what can I say? At least you're too afraid to identify when you disagree with him. I'm not afraid.
Particularly on the air cart track experiment, calling him a liar, saying you said he's cheated. He's cheated the experiment. He's a cheat, and you do call him.
Yes, exactly. I think that's an absolute fact. I think it's a demonstrable absolute fact that they couldn't get the experiment to work the right way, doing it the right way, so they did it the wrong way, and I've used Veritasium as an example. He clearly couldn't get the single photon experiment to work the right way, so he cheated the fuck out of it. Fact.
Names. So when it suits you, you say one thing, and when it doesn't, you say another. You're unreliable.
No, that's a complete lie. I've never said Professor Lewin is the man to go to. I said it's great that he does experiments. A lot of his experiments are really good. Unfortunately, a lot of them are very old, and they're not his. He didn't originate the shoot the monkey thing and the other experiments. The radar experiments are all stuff done in the 50s. I've played those videos. There's absolutely no duplicity or agenda in anything I'm saying. I'm just arguing with the arguments physics is making, and I'm pointing out the arguments that seem credible and the arguments that seem quite incredible. And I'm just saying to you, show the same consistency. If you're going to say Professor Lewin is wrong because you've invented some new physics that's right, Well, then you have to make the argument. Accuse him of cheating the experiment or something. Explain why he's wrong to think twice the mass, half the velocity. Show why he's wrong. But you're not doing any of that.
I can't think of the other words. There's plenty of them. But
I mean, I showed why I think his air track experiment was a pile of shit. I pointed out all of the missing things on the carts, how the clay was smashed up, all the shit. I showed all the defects in the experiment. I showed why I'm pretty convinced it's a fake experiment.
Yeah, that's all wrong, Gary, what you say there. Now then, going back to this spring business. If we dropped a weight, I thought this was a rubbish idea anyway. I said it to you because you were quite keen on it. I thought, well, I suspect that if you did do it, you can't measure energy by dropping things on a scale. They're not designed for it. You get a lot.
They're just springs, okay? And all they are is going to measure pressure. There's pressure hits the metal. The pressure has to be spread over the spring. The spring will, in fact, compress a certain amount. Yes, it is quite doable. Springs can measure impulse energy. Not a problem.
The energy is lost in shock, the impact force and vibration.
So he's just making up words like inertia. Springs are always shock. There's no way to not shock a spring. Okay? They're always... That's why they make shock absorbers out of them, because that's what they do. They're shocked, and they take the shock and store it, and then they give it back.
And the scale
later,
vibrates about. You couldn't read it accurately. It's a terrible experiment.
So he's saying this is a terrible experiment when, no, it's a really good experiment, frankly. Moving a spring, compressing it, storing the energy in a battery is a really good experiment. It's a good way. Frankly, that's how meters work, is they store the electricity. They collect it and store it and give you a reading of, what's the energy. So again, he's like saying oscilloscopes don't work or something. They're shocked. You can't use that device to measure electricity. Of course you can. Springs work.
I suggested it because I thought, you wouldn't. These two drops wouldn't give you the same. You would see a difference. You would, and that's why you haven't done it. But the problem is, kinetic energy.
Did he say that's why I've done it? I don't know. I don't know what he said. I think he hasn't done it. So he talks about speaking English, and then you can't tell whether he says have done it or hasn't done it. Really shouldn't be giving proper English lessons.
These two drops wouldn't give you the same. You would see a difference. You would, and that's why you haven't done it. But the problem.
That's why I've done it. That's why I haven't done it. That's why I haven't done it. That's why I haven't done it. Okay. Well, yeah, I can't make much out of that record. Well, maybe I could make something out of it, actually. It's kind of a catchy tune already.
The problem is, kinetic energy says that you get twice the energy out.
And I'm pointing out that scales are pretty much energy detectors, and that if you could make a scale small enough, you could detect an electron's energy. You make a scale, scales collect the energy and show you a reading, and then they give it back, and you can make it so it doesn't give it back. You can turn them into batteries if you want, and hold the energy inside the spring. Just a fact. It's an energy detector and an energy storing device. It just works. It's really good to do that. Just like the oscillating lever is a good storage device. Now, obviously, if you got to take it out of the air, and you can make it last a lot longer because it won't lose anything to air resistance, air weight. It won't have to push the air around, and so it'll keep its energy in the system longer, and you can make more perfect bearings and all that kind of crap, and maybe ideally if you could do it from space, it would oscillate forever.
Which is right. But if you were expecting this to measure twice, if this measured 10 here, and you were expecting this to weigh twice 20, you'd be wrong. Because the spring It goes.
Well, okay, so he keeps saying I'm wrong. He won't do his own experiment. He has the device to do it. He can just drop the weight on the springs and see what they do. So he can do it, and he doesn't do it. So what the fuck's the point of this nonsense? He's telling me it's wrong, and he's not going to give me any reasoning that demonstrates it to be wrong. Twice the velocity is twice the weight, is twice the momentum. It will compress the spring twice as much.
It's back to this formula. If you double the compression of the spring, you've got 4 times.
So he's still saying the formula is correct, and I keep saying no, it's not correct. It doesn't work. It doesn't get the right answer. I didn't even have the 1/2 in front of it until the late mid 1800s. So they didn't even have the half attached to it till the mid 1800s, and you're sitting here telling me this is the correct answer when for 100 years they had a completely incorrect answer. I mean, sorry, pathetic.
Energy. So that's right, yeah. When you said you drop one weight, one mass, one velocity, and then you drop the same mass, twice velocity, it weighed twice. So you were saying, well, yeah, twice the energy, twice the distance, twice the time.
No, it's 4 times the distance. So again, you keep doing that wrong, okay? It's 4 times the distance. 4 times the distance, only twice the velocity, only twice the time free falling. So again, key, only twice 9.8 meters per second, so to speak. Only 2 units of 9.8 meters per second. And yes, twice the weight. That's all. Bunch of 2s are the right answer. The 4 is just the suckers fall for that.
Twice the energy. That reading of twice the amount on here means 4 times the energy. Now, I know you won't accept that.
I have no reason to accept it. Hooke's law says it's nonsense. That's your theory is a free energy pile of nonsense. It absolutely does not take 4 times the energy to compress the spring twice as much. Doesn't take 4 times the energy. Can't possibly be the right answer. Can't possibly be the truth. There is not 4 times the energy and twice the compression of the spring.
But this is the problem. And because by doing this experiment with half the mass, we would only be registering double the energy, the actual scale wouldn't be reading double what this one did. It would be somewhere more than this. But
he keeps saying it, okay? He just says it. All right. So, no, it wouldn't. No, it won't happen that way. If we get the Mythbusters to do the experiment, they're not going to get your answer.
But a lot less than double. And I thought you won't see that when it's vibrating about with the impact and the vibration. You won't see it. It won't be clear. And he'll say, oh, look.
Again, you're not going with vibrations. You're going with the maximum reading. So there's lots of ways with a scale, especially to do a Stephen Bro. I mean, Stephen was rather, innovative. You put a very light substance on the surface, or you have it hang or something. And then when the scale goes to its maximum reading, it'll leave it behind at that reading. So all you need is some kind of mechanism that leaves a mark. A pencil, you could tie a little pencil to this and draw a line, like a seismograph. It would absorb a tiny bit of the energy. You would lose a tiny bit of energy, and you would have a clear reading of exactly what the maximum reading on the scale was. The maximum reading is the reading. The oscillations are just happening afterwards. They have nothing to do. They just have to do with the fact that you're not storing the energy completely. You're storing it incompletely.
There's no difference. So I don't think we can use scales to measure this energy.
Liar.
So another idea I had, what if we dropped the weights different distances?
I mean, idiot.
And used it to pull up a weight over a pulley or something. Drop the weights here.
Yeah, that's what regular conventional physics does. A lot of these other mechanisms that end up, making the conversation more complicated than is necessary in terms of making forces go up and down and up and down, and so it's more balls to follow. So, I don't see any point in doing that, frankly. I don't see how that improves the experiment at all, because you're just introducing a bunch of friction points. That means the objects won't move until they have enough momentum to break free of the friction.
And it pulls this weight up We measure it, put a ruler there. We drop one weight, one distance, measure it, how far this weight goes up. And then we drop another weight, or the same weight, at twice velocity, say, 4 times the height. And
where is there any evidence that this would be more consistent than a spring in terms of how it collects the energy? Because you would be obviously changing the amount of friction and force on the pulley constantly as the object hits. So I don't see how this stores the energy more efficiently. It's attempting to transfer the energy, and it's not an efficient transfer, frankly. You can't get more efficient in theory than the direct transfer of energy from one object to another object, in the case of a spring, for example. That's more direct than this is. This is highly indirect, and there's lots of places for you to create resistive loads that will take the energy.
this weight should go up, according to your theory of mv is the energy, the same height. If it went up more, which kinetic energy would predict, you'd have to find another one of your excuses what was wrong with it. But
whatever. Yeah, there's always explanations. It's physics, okay? And there, like I said, you're adding more dots to the picture and saying there's more, you're going to make it more complicated. I'm saying that I don't see any necessity to make it more complicated than the lever or the gear or the pressurized vessel. I think those are as elemental and as basic as you can get, and you're the one who won't touch those. You won't touch them with a 10-foot pole, as they say. Chicken shit.
I think that would be a good indicator. You'd have to put a spring somewhere in here, because as the weight drops, you couldn't have it suddenly having a shock stop again.
Again, there's shock crap. If it's a steel wire, the shock is going to be limited. Something very inflexible, something as inelastic as possible, so it doesn't do any stretching or any of that kind of crap. You want to take springs out of the experiment. You don't want devices that are going to store the energy. You want to measure the energy. You don't want to dampen the energy. So even what you're arguing is nonsense. Dampening the energy won't allow you to measure the energy.
You lose the energy because you've got to decelerate it, so we'd have a spring to decelerate the falling mass. And then that force.
So again, I've been over this acceleration deceleration thing. It has really nothing to do with things like Newton's cradle. It has to do with the transfer of energy, and your whole concept of measuring little microscopic distances and saying it accelerates at a rate when no, it really doesn't. It just goes from being stationary to going 60 miles an hour, and that's basically how the Newton's cradle works. There is no acceleration and deceleration. There's really just stop and go.
Spring was applying would also be lifting this mass up here, and we'd measure it on the ruler. You've got to decelerate the force, otherwise you lose it through shock.
No, you dampen you take the energy out of the system by dampening it. So you're just dragging something across a surface and pretending that all of that drag is somehow going to be a measure of something, when no, it won't measure anything. So Galileo will prove that. You can build a ramp, and the ramp will allow you to slow everything down and expose things to a lot more gravity. But the key is the ramp will actually absorb all of the extra gravitational force you created. So all the extra time will be absorbed in friction. So your end result will be as if you dropped it free fall in terms of your velocity, except for the angular momentum. Alright, so absolute pile of shit. But at least it's a video with something in it. Okay, so most of it was just straw man nonsense. Okay, conversations about ludicrously silly experiments that I haven't suggested and nobody else has suggested, and he's just making up crap to create noise. So it really was a pile of shit in so many ways. And surprisingly, only 2 comments. I don't know how old it is, but anyway. So, mindless marbles. There was a comment here by some other asshole. Yes, the Gosling asshole. No, the Steve Golfrey. Yeah, he made a comment, and all of a sudden it's gone. I wonder where that went. Maybe it's on the Dispar video. Okay, so we'll go find that one. Mindless just keeps saying the same thing. F equals ma. He doesn't. Yeah, there it is. Okay, yeah, people like to explain this by separating the concepts of inertial mass used in F equals ma. So again, it's not about the mass that's the problem. The problem is what you do to acceleration, and that is you pretend that the rate of acceleration is a squarable function for some reason, and it's not a squarable function. You don't square the rate at which something accelerates. Absolutely no good logical reason to square it, just as there's no reason to square the velocity. Okay, the gravitational mass used in F equals g times m1 m2 divided by r squared, and then nothing that the two happens to coincide. I don't know what that could mean. Used, and then noting that the two happen to coincide. I don't know what coinciding there is. There's no coinciding at all. The r squared is because it's separating in two different dimensions. I don't see what that has to do with you squaring a velocity. Galileo made a thought experiment about this. Imagine two balls of equal mass, size, shape, etc. falling side by side. Since they are identical and side by side, they would fall together at the same speed. This isn't that's not even, obviously he did that in real life, so I don't think that's a thought experiment. Now imagine a tiny little spring connected to the two objects onto one object. Connecting the two objects to one object. So there's a third object, I don't know, into one object. Okay, so there's a spring connecting the two. One's above the other one, I think is the argument. Clearly a tiny little spring shouldn't have any effect, right? Or there would be, or if there is any effect, it could be minimized. Well, if it makes no difference, then the two combined objects should still fall at the same rate, plus the added mass of the spring. So whatever the added mass of the spring is. Yes, the rate they fall will not change. Hence, by doubling the mass, the rate of falling doesn't change. I don't know what that even means. The rate that the atoms collect momentum can't be changed. It's 9.8 meters per second. Doesn't matter how big or small the object is. One atom falls at the same speed as the Empire State Building. Okay, ignoring air resistance and whatnot. There's no surprises here. So what are you arguing? Oh, that's right, nothing. Straw man nonsense. Nowhere in any of my theory have I said it happens any other way. The force changes or any of that stuff. I'm saying the mass is collecting the force. Period. The video dealing with lifting weights to compress a spring. A video dealing with lifting weights to compress a spring. So who knows what this will be. Oh, it's his own video. Fuck that. We've already been there and done that. So we're not going to do it again. That's for sure. It's just too stupid. He's just making up a fake story that it takes 4 times the energy to lift the second battery to the top of the scale. So I lift the battery, put it on the scale. It weighs 1. I lift the second battery, and now it weighs 2. He's saying that's 4 times the energy. The second battery somehow made 3 units of energy extra. No, it didn't. Nonsense. Same work, same energy. Alright, so we want the dispar video. That's not it. Alright, well I guess we'll just use this window and put it in here. I guess that's what we'll do. Alright, so there's no audio on the experiment, so he's just dropping clay, and again, you don't get to see much at all, so there's nothing to say really. You can't really see the maximum reading. It's something like 200, something like 200, 200, 200, 200, right. Now he does the half mass from 4 times the distance. 4 times the distance, blah blah blah, drop drop drop. See, again, not quick releases, but whatever, and it goes 200ish. That's it. So yep, same momentum, same weight. Momentum is weight. It's just as silly to argue otherwise. I don't know why you would bother wasting time arguing otherwise. It's just too obvious. Fuck this shit. All right, I don't see the comment by the moron, so it is actually missing, it would appear. Let's see what this one is. Typo in the title. I assume it should be 4 times the height, alternatively 2v. So I don't know. I guess he made a mistake in the title somewhere. Whatever. Who cares? So this is more just bullshit, fake math, nonsense math, whatever you want to say. Well done for trying. Okay, so let's do the Gosling comment. So we'll just post it in here. I mean the Steve Godfrey, lying sack of shit, troll fucker, who doesn't know shit. Okay, so he said, this is where you'll see Gary's sleight of hand kick in. He'll say that the scale jumped to 200 proves his point that weight's changes depends on something like the velocity. Yeah, I think the velocity is exactly what matters. It matters how fast you hit a scale. So you hit a scale with a mass that's moving a velocity, and that will deflect the scale. So all I do is take a 100-pound person, say run 10 miles an hour and bang into it, run 20 miles an hour, bang into it twice as much, 40 miles an hour, twice as much as that. That's Galileo, Newton, and Descartes all understood that. That is hard, good physics, frankly. All right, proves his point that weight changes depending on something like velocity when an object hits the scales, or time spent in gravity. Yes, that's what Gary argues. There's no sleight of hand. It's an overt accusation about how the mechanical physical universe works, and you're not counter-arguing anything stated. All right, this has enough appearance of truth to misdirect from the deception. So somehow it's looks like a truth, but there's an obvious cheat or deception in it somewhere. I'm pleading with you to point out the deception. I'm asking them to draw a lever. I'm asking them to draw gravity and explain how it's not a time-dependent force. And they won't do it. So they won't explain why it isn't the truth. Weight equals mass times gravitational acceleration. Again, it's just gravitational force, but you want to call it acceleration, that's your business. It really isn't about acceleration. It's just about force collection, energy collection. This explains why an object will have different weights on different planets. Yes, who cares? That's not relevant to this argument at all. We're not talking about different planets. We can all understand that gravity on the moon is only 1/6 what it is here on Earth, blah, 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 not a problem. Because gravitational acceleration varies according to location. Yes, the rate of acceleration, it's not 9.8, it's 10.7, whatever, 100, I don't know how high you have to go. I don't know, I really don't know how high you have to go to actually change it to 8.8. Okay, so maybe that's 10 miles. Maybe it's 100 miles. Even different places on Earth. So yes, weight does vary depending on gravitational acceleration, but it isn't what Gary's driving at. Well, so why are you bringing it up? Yeah, obviously I don't give a shit about changing the rate. We're not talking about we're talking about what the rate is. Is it a time-dependent rate or is it a foot-dependent rate? It's 9.8 meters per second. My obvious argument is a second is a time unit. It's in time units. It's not in foot units. All right, the key to understanding his nonsense, okay, my nonsense is that 9.8 meters per second does not mean 9.8 meters per foot, is that weight is calculated on the assumption other forces aren't acting on the object. Well, every argument is made in this context. We're saying, okay, let's ignore air resistance, let's ignore all these little superficial bullshit things and just say, yes, we're just going to concentrate on this key factor, the gravitational force. And obviously when you drop something, it's pretty much obvious that gravity is the only force involved. Dropping the mass brings other forces into play. So that's just an absolute lie and a pile of shit. And they're the reason why the scale measurement jumps up for a moment. So he says there's some other force pushing the scale down. I think that's just too retarded. The fact something other than mass and gravitational acceleration are affecting the scale, so there's nothing else affecting them but the momentum of the object. The momentum of the object has been derived from gravitational acceleration. That is the gravity being collected by the object. So just like you being pushed by a wind into the scale sideways, we do the experiment. I push you with some mechanism. I give you a velocity. Your velocity compresses the spring. Same exact thing is happening in gravity. You're just collecting a different kind of force. The scale jumps deflecting something other than weight. Okay. The scale jumps is detecting something other than weight. So this is just this is why he deleted the comment, no doubt. It's because it's just absolute nonsense. There's absolutely no evidence that I have, cheated by not showing the other force that was pushing the scale. There is no other force. So when he says dropping something from a height makes it heavier, I'm saying if it's free falling, it's collecting energy. So yes, if it's free falling, it's collecting energy. He's changing the definition of weight from weight equals mg, so there's nowhere where I said any such thing, to weight equals mg seconds. No, that's not what I said either. So I never said any such thing. Weight is mass times the force, the velocity. They convert into each other. There's no changing of the mass, so we can just say that's a constant. And we're just going to say what's really causing the weight. Well, the velocity is causing the weight. So no reason for this second. I'm saying it's not mgh, it's mgt is the right answer. Mgh thinks that it's a per foot force when it's a per time force. 2 seconds to drop 4 times the distance. Mgt gives you obviously the wrong answer. 4 is different than a 2. Well, so you're going to get the wrong answer if you use mgh. Something else, time spent in gravity freefall. Yeah, so I don't know what IOW means. He isn't talking about weight at all. So I don't know, how can somebody miss the subject? I keep saying it, that the scale is a energy detector, that energy is weight, is pressure, is heat, is everything you talk about as being a form of energy. It's all just energy. Okay. He's talking about something he pulled out of his ass, so whatever that even means. So clearly I've made the argument that this is an energy detector because it detects momentum. And if you want to find momentum, you want to find energy in the universe, you just look for momentum. Momentum is energy. There is nothing else that makes energy but objects that have a mass and a velocity. Not a velocity squared, just a mass and a velocity. And that'll always get you a right answer. It'll always be correct. It is how the actual universe worked. Newton, Descartes, and Galileo were not famous for no good reason. They were famous because they understood that, and they explained how the universe worked very well and very correctly and very accurately. And you, on the other hand, are just a lying, trolling, privacy invading, malicious, petty, dickless wonder. You are just a perfect example of why human beings deserve no mercy. You are scum. You have no integrity. You're just lying sacks of the smelliest possible formation of shit. Yes. You are just such an insult to the concept of intelligence. Alright, so that's probably enough. Now we'll go see what the chatters have to say and then get the hell out of here. Disappointing as usual. Alright, nothing. Oh, so great. I won't have to waste too much time. Alright. So James didn't bother with an explanation, so we can just get rid of him. See you later. Fuck off. I mean, people just waste time for no reason. I'm going to tell a joke. The jokes are fun. Shit. Not on my time, you're not, fucker. Anyway. So, 2-minute warning. Just letting you know. 2 minutes. Could say something like, boy, that Ian guy sure does lie a lot. That would be an acceptable comment. seems kind of desperate if you have to lie in your video so many times. That seems like you must not know the truth. You must not have the truth if you have to lie all over the place and lie about what the other guy said or what the other guy implied. Boy, if you have to do that, you must have a pretty weak argument. You know, that's like being Superman and not wearing your Superman suit. I mean, why wouldn't you wear your Superman suit if you're Superman? I mean, you know, it's a perfectly good suit, you know. Makes it clear that you're Superman. Why? Geez, no point in being Superman if you're not going to wear the suit. Oh. Come on. Why would you wear the bummy, cheating coward suit? If you're coming to the rescue, you know, you probably should do that without a bottle of whiskey in your hand. All right, 38-second warning. Guess we might as well see how many people are here. I'll let you know before I go, I guess, just for the fun of it. Let's see what kind of performance we have. 13, that's about the number. It's pretty much the average, unfortunately. So the good news is later in the week, sometime this week, we should have the video from the Michael, I believe his name was, Physics Michael. And we'll see if he has some reasonable arguments to add. Showing us that it does in fact take 4 times the fuel to go twice as fast. Maybe he'll be able to show us that piece of evidence. You know, something real. Yeah. Maybe. Alright, well, till the next time and such. So, well, at least I wasn't irritated by commenters, so that's... So I guess that's an improvement. So anyways, till the next time and such.